So, let me start with attendance. John Agee. Devontae Alexander. Jerry Patrol. Caleb Davis. Mason Doan. Armando Gonzalez. Marshawn Harris. Jay Henderson. GEOL110. Nathan Colossa. Riley Mack, I'm sorry, Andrew Levinson. Okay. Riley McIntosh. David Skew. Caleb Milton. Morgan Shue. Kirsten Smith. Samantha Smolin. And Deuce Webster. Okay. So chapter 18 homework is going to be due today on WebAssign. The chapter 18 quiz is today in class. Exam number 3 on chapters 16 through 18 is on Thursday. You get one sheet of notes. You can use a calculator. It's 75 points. The slides I handed out here are general review that are up on Blackboard for the SI. Their handout, I will be doing a review as well. So I'll be going through all the review questions at the end, and I can go over a few of those questions from the review packet if I have time. And we will have our quiz. I'm going to try and do it around 9:15. So the sun and the planets, they orbit the Earth in the geocentric model of the universe, where the Earth is at the center and everything is orbiting it. And in the more accurate model of the solar system, the Earth and the other planets orbit the sun in what's called the heliocentric model. The orbits of the planets are generally in the shape of ellipses. The orbits of everything orbiting the sun are mostly in the shape of ellipses. The law of elliptical orbits was developed by the scientist Johannes Kepler. He developed Kepler's 3 laws, which describe the orbits of the planets. An astronomical unit represents the average distance of the Earth from the sun. And it's the tool we use to measure distances within the solar system generally. And when a planet is closer to the sun, its velocity is faster. When it's further from the sun, its velocity is slower. So the point where the Earth is closest to the sun is called the perihelion. The point where the Earth is furthest from the sun is called aphelion. And those terms apply to any orbit. Perihelion is the closest to the thing you're orbiting. Aphelion, aphelion is the furthest. Actually, those are, strictly speaking, those are about the sun. The helion part means sun. but anything orbiting the sun has a perihelion and an aphelion. I think the term is slightly different when it's orbiting something else. So it might still be used. I can't remember on that one. Planets with orbits that are smaller than Earth's are called inferior. Planets with orbits that are bigger than Earth's are called superior. These are using the old Latin terms, which mean above and below. Because if your orbit is smaller than us in some way, you're below us. The planets all revolve around the sun in a counterclockwise direction. Name? And all the planets rotate counterclockwise as well, except for the planets Venus and Uranus. Venus rotates clockwise. Uranus technically rotates clockwise, but it really is on its side. But its orbit is such it's ever so slightly dipped so that, the clockwise rotation is pointing ever so slightly up. Non-gaseous planets are referred to as terrestrial planets, while the gaseous planets are referred to as Jovian planets. Terrestrial planets are Earth-like, thus terrestrial. The Jovian planets are Jupiter-like, thus Jovian. The planet closest to the sun with the shortest period of revolution. So revolution is orbiting around the sun, rotation is orbiting around your sun. It is spinning. So you revolve around the sun, you rotate on your axis. The planet closest to the sun with the shortest period of revolution is Mercury. The planet with a thick atmosphere of carbon dioxide is Venus. Venus has the hottest surface of any of the planets because of its thick atmosphere of carbon dioxide. Planet with a thin atmosphere that appears red in color is Mars. It's red because of the iron oxide on its surface. Fastest rotating, Jupiter. Generally, the more massive things spin faster. Is how it sort of works out. But yes, Jupiter is the fastest rotating. Mars has the largest volcano in the solar system. And the gaseous planets are composed primarily of the elements hydrogen and helium. The largest planet is Jupiter, and it has the fastest period of rotation. The planet with the most prominent ring structure is Saturn. And Uranus and Neptune both have a blue tint due to the gas methane in their atmospheres, which scatters blue light. And Pluto is classified as a dwarf planet because it is not big enough to clear its orbit of other material. It doesn't dominate its orbit. And the most current theory of the formation of the solar system, approximately 4.5 to 5 billion years ago, is the nebular hypothesis and condensation theory, which is that it started as a cloud of gas and collapsed and condensed to form the sun and the planets. So that was chapter 16. Chapter 17, natural satellites are referred to as moons. So those are, naturally occurring things that orbit something, a planet. Our moon is the largest in size of any moon orbiting the terrestrial planets. There are only 3 moons orbiting terrestrial planets, our moon and Mars's 2 small moons, Deimos and Phobos, which are dinky, relatively. Our moon is like the 5th biggest moon in the solar system. It's weirdly big. compared to the size of the planet. We only see one side of the moon since its period of rotation on its axis and its period of revolution around the Earth occur at the same rate. So as the moon travels around the Earth, it rotates just right, so the same side is always facing the Earth. The gravity of the moon is only 1/6 that of Earth. So if you know how much you weigh on Earth, divide it by 6, you'll get your weight on the moon. Radioactive dating has shown that the moon's age is less than that of the Earth. It's younger than the Earth. Currently, the moon does not possess any significant magnetic field. And bowl-shaped depressions on the moon's surface are referred to as craters. The light-colored surfaces of the moon are referred to as the highlands. The dark-colored surfaces of the moon are the lunar plains or the maria. Because they look like bodies of water because they were darker. So they called them maria, meaning seas. Highlands. That's because they're higher in altitude. There's nothing special about that. They're literally higher up. And these dark areas are theorized to be the result of ancient volcanic activity on the moon. They're large impact craters that flooded with lava, which cooled to form these dark areas. And the streaks radiating outwards from some moon craters are called rays. The long trenches on the moon are called rills. And the moon's orbit is tilted 5 degrees with respect to the Earth's orbital plane. So the orbit of the moon and the orbit of the Earth are not quite in the exact same plane. It takes the moon about 1 month to revolve around the Earth. The phase of the moon when the moon can't be seen is called the new moon. The phase of the moon when the full disk of the moon can be observed is called the full moon. If the moon is getting larger, we say it is waxing. If it is getting smaller, we say it is waning. If less than half the moon is visible, we say it is a crescent moon. If more than half the moon is visible, we say it is a gibbous moon. When the moon is between the sun and the Earth, a solar eclipse may occur. And when the Earth is between the sun and the moon, a lunar eclipse may occur. Then, that's the packet that you can look at. The darkest shadow region during an eclipse is called the umbra. The somewhat dark region around the umbra during an eclipse is called the penumbra. Tides are the greatest on Earth when the moon and the sun are in line with Earth. When the Earth, moon, and sun all form a straight line. And there are 2 high tides and 2 low tides each day on Earth, because there are 2 bulges. One on the side facing the moon, one on the side far from the moon, and the Earth rotates through both of them. So you get 2 highs and 2 lows. When the Earth, moon, and sun are in line, this forms spring tides. They spring up, is a way you can remember that. And when the moon is at first quarter and last quarter, the smaller tides are called neap tides. These are less extreme tides. I don't have a good way to remember that. The two terrestrial planets that have no moons are Mercury and Venus. The Jovian planet with the most moons is Saturn. Your book might say Jupiter, but that's a little out of date. I think it's been updated though. I don't recall. I had to change the answer on the question. The moon, Jupiter, the one of Jupiter's moons that has lots of active volcanoes is Io, the most volcanically active place in the solar system. The planet that has the largest moon in the solar system is Jupiter. That moon is called Ganymede. What the moon Titan has that is unique for a moon is a dense atmosphere. And Titan is Saturn's biggest moon. The planet that has a moon that resolves in a retrograde orbit is Neptune, and that moon is called Triton, not Titan. Titan, Saturn, Triton, Neptune. Triton, as in trident. Triton is a son of Neptune, while Titan is the people who came before the gods, the Titans. And that's Saturn is a Titan. So Titan is the moon of Saturn. Triton, with the tri in it, is the moon of Neptune. Pluto is classified as a dwarf planet. And the collection of small bodies between the orbits of Mars and Jupiter is called the asteroid belt. And these are asteroids. A meteoroid that reaches Earth's atmosphere and glows brightly as it burns up is called a meteor. A meteoroid that reaches the Earth's surface is called a meteorite. So in space, it's a meteoroid. In the atmosphere, it's a meteor. Once it's on the ground and it's now a rock, it's a meteorite. Comets usually have a very elliptically shaped orbit. They spend most of the time far away from the sun, and they get close to the sun for a short period of time. The rocky portion of a comet is called the nucleus. The glowing part of the comet that forms as it approaches the sun is called the coma. The rear portion of the comet that's composed of ionized material and dust being blown away from the sun by stuff being emitted from the sun is called the tail. And then the portion surrounding the coma is thought to be a cloud of ionized hydrogen gas. I think it's ionized, but it's hydrogen gas. There's a cloud of hydrogen gas around the coma. And the tail of the comet is pointed away from the sun as it approaches, because the material in the tail of a comet pocket is up here, is being blown away from the sun by, well, a couple things. Thank you. The light of the sun and the solar wind. The universe, so that was chapter 17. Chapter 18. The universe is the totality of all matter, energy, and space. The huge imaginary sphere of the sky on which all the stars seem to be located is the celestial sphere. The path the sun takes across the background of stars is called the ecliptic. A parsec, which is the distance 3.26 light years, that's the distance to an object with a parallax of 1 arcsecond. The layer of the sun that we see is called the photosphere. A apparent magnitude is a measure of the brightness of a star as seen from Earth. If you were to measure the brightness of the star seen from a standard distance, which is 10 parsecs, that would be absolute magnitude. So apparent magnitude depends on the brightness of the star and how far away it is from you. Absolute magnitude corrects for distance and is the magnitude it would be if it was at a fixed distance of 10 parsecs, which is 32.6 light years. And the Hertzsprung-Russell diagram, or the HR diagram, plots stars' absolute magnitudes versus temperature of their photosphere. And the band of stars from the upper left to the lower right in the Hertzsprung-Russell diagram that most stars fall into is called the main sequence, because it looks like a sequence. It's going from one corner to the other, and most of the stars are out. So it's the main sequence. The relatively cool, bright stars up in the upper right-hand corner of the Hertzsprung-Russell diagram, with diameters 10 to 100 times that of the sun, are the red giants. And in the opposite corner, the small, hot, dim stars left behind by the death of a low-mass star are called white dwarfs. So red giants are cool and bright. So to be bright and cool, you have to be huge, hence red giant, and they're red because they're cool. And white dwarfs are incredibly hot, but dim, which means they have to be tiny. And so those are tiny, hot, dim stars in the other corner. Nebula are cool, denser clouds of interstellar gas and dust. They look like clouds, hence the name nebula, which means cloud. It derives from the Latin for cloud. A shell of gas ejected from an old low-mass star is a planetary nebula. You'll see the white dwarf in the center, and then there's a surrounding circular, generally, shell of gas around it. People thought it looked like a planet or a planetary system. A white dwarf star that suddenly increases dramatically in brightness for a brief period of time is a nova. When a star explodes, that's a supernova. Other than hydrogen and helium, all of the elements up to iron are thought to be made during normal fusion processes in stars of various masses. And all elements heavier than iron are made in supernova explosions. That's the basic idea. The actual process is more complicated than that. We don't need to worry about that for this. A neutron star is the extremely dense remnant of a high mass star that's made entirely of neutrons. So it's like an atomic nucleus the size of a city. It's insane. And a rapidly rotating, one of the above, rapidly rotating neutron star that appears to pulse on and off is called a pulsar. And that's because neutron stars have super strong magnetic fields, which are not necessarily aligned with their rotation. So as they spin, they emit a beam of radiation along their magnetic axis, and that sweeps out. And as that beam passes us, we see it as a pulse of light, or radio waves usually. A black hole is an object so dense that not even light can escape from its surface because of the object's intense gravitational field. So once gravity is so strong, nothing can escape, it is a black hole. And a large gravitationally bound collection of stars and gas is a galaxy. Galaxies come in three basic types: elliptical, spiral, and irregular. And the spiral type, there's two types of spiral galaxies: normal spiral and barred spiral. A globular cluster is a spherical collection of hundreds of thousands of gravitationally bound stars, usually found in the outlying regions of a galaxy. Irregular. So elliptical, spiral, irregular. The additional mass required to keep galaxies gravitationally bound that we can't see is called dark matter, because we can't see it. The study of the structure and history of the entire universe is called cosmology. Hubble's law says the further away a galaxy is, the faster it is traveling away from us. And the force that appears to be accelerating the expansion of the universe is dark energy. Again, because we can't see it. And the universe is expanding because the space between galaxies itself is expanding. Space itself is expanding. So the Big Bang theory of the beginning of the universe says that the known universe was smaller, hotter, and denser in the past, and then it began rapidly expanding about 13.8 billion years ago. There's some debate on whether it's 13.8, 13.7, 13.6, but around that. And the echo of the beginning of the universe that provides evidence of this above theory is the cosmic microwave background. You are literally looking back to the point where the universe became transparent. Much like when you look at the sun, you're looking in until the sun stops being transparent. It's more or less the same thing. The point where the universe cooled down enough that atoms formed, electrons combined with nuclei. That point, which was about 380,000 years after the Big Bang, that is what you're seeing with the cosmic microwave background. And it's more or less the same in every direction. And in the very early universe, hydrogen and helium were created in a ratio of 3:1 by mass. So, for every 3 grams of hydrogen, there was 1 gram of helium. We have a little more time, so I'll go over a couple of things. Okay, so I'll close that. Oops. From the general review, this should be up on the SI Blackboard. Come on, why are you not opening? So I'll go over a couple of these calculations. So here, let's go over how to calculate the distance in parsecs to a star. So if we have the star Sirius, the annual parallax of the star is 0.38 arc seconds. The equation to calculate the distance is 1 over the parallax angle in arc seconds. So the distance is 1 over the parallax, which is 1 over 0.38, which gives you 2.63 parsecs. And if you wish to convert that to light years, 2.63 parsecs is 3 times 3.26 light years per parsec, gives you about 16 light years. Additionally, one of the things you can do is you can calculate the age of the universe based on the Hubble constant. So if the Hubble constant was only 50 kilometers per second per megaparsec, the equation for the age of the universe would be 9.78 times 10 to the 11 divided by the Hubble constant. And this is just a unit conversion. It's a big fancy unit conversion. Because this thing, if you work it out, has units of 1 over time. It's just, they're really weird units of 1 over time. So if you convert this to 1 over years, which is what this constant does, and do 1 over it, basically, that'll give you the age of the universe in years. So if the Hubble constant was smaller at 50 kilometers per second per megaparsec, the age of the universe would be 19.6 billion years. Since we have a few more minutes, I'll go over a few more of these questions. So which of Kepler's laws gives the most direct indication of the shape of the orbit of a planet? That is the law of elliptical orbits. The law of equal areas tells you about how fast that planet moves, and the harmonic law compares between different planets, the time they need to orbit based on their distance from the sun. Which of Kepler's laws gives an indication of the semi-major axis? That is the harmonic law. It compares how far it is from the sun to the time it takes to orbit. Which scientist discovered the phases of Venus? That was Galileo. Which gas is abundant in Earth's atmosphere, but not for the other 7 planets? That is oxygen. Oxygen is not common on most planets, mainly because it reacts with stuff. And we have plant life keeping oxygen in our atmosphere, basically. The Foucault pendulum is an experimental proof of what characteristic of the Earth? It is proof that the Earth is rotating. Revolution is movement around the sun. Rotation is what the Foucault pendulum measures. And I think I calculated it here. If you have a Foucault pendulum here, it's about 36 hours to go around. I'll work that out. And there's a couple of them at the Museum of Science and Industry if you want to see it. Terrestrial planets have which of the following characteristics? They're primarily composed of rocks and metals. Surfaces of mostly ice is something you get in the outer solar system. Large ring systems, something you get with Jovian planets as well, and strong magnetic fields. Again, the Jovian planets have much stronger magnetic fields. Which of the following statements concerning the terrestrial planets is false? Name? Sorry, can you repeat that? Ah. And here is and the first one, Mercury and Venus can never be in opposition. They can be in opposition. They all have magnetic fields. They're not huge except for Venus, kind of. They all. Oh no, it's number C. That one is actually several of these are false. The first 3 are all. I'm not sure. Let me check the answer key for this. This is a weirdly posed question. Okay. Oh, that's an opposition as seen from Earth. Yes, Mercury and Venus can never be in opposition as seen from Earth. I was thinking opposite sides of the sun. That can happen. But they can never be in opposition as seen from Earth. Because you'll never have, they'll both be towards the sun, closer to the sun. But they all rotate clockwise. viewed from above from the North Pole is false because Venus rotates counterclockwise. Which of the following is not a physical characteristic of a terrestrial planet? Relatively low density. They're relatively high density. The primary constituents of the atmospheres of Jovian planets are hydrogen and helium. The physical characteristic that is not characteristic of a Jovian planet is relatively high density. They're gaseous, they have rocky or ice cores, and they rotate quickly. Which planet has a ring system made of mostly water ice? That is Saturn. Which Jovian planet revolves on its side and has retrograde rotation? That is Uranus. Which of the following criteria disqualifies Pluto as a major planet? It's the orbit is clear of other objects. It fails to meet that. It's an orbit around the sun. It has sufficient mass for a round shape, but its orbit, the other stuff in its orbit is, significantly more massive than it. And as a fraction compared to Earth, how much would an astronaut weigh on the moon? 1/6. What causes the prominent ray features on the moon? That is impact craters. And most craters on the surface of the moon are believed to be caused by which of the following? Meteoroids. Some of them were probably caused by asteroids, but meteoroids is the more general term. And during 1 month, the moon passes through how many different phases? 8. And a solar eclipse occurs during what phase of the moon? The new moon. Spring tides. When do spring tides on the Earth take place? Near the times of the full and new moons. Which of the following planets has no moon? Venus. Which of the following is the largest moon in the solar system? Ganymede. Which dwarf planet has 2 moons? That is Haumea. Pluto has 5, Ceres has none, Eris has 1. Which of the following is not true of comets? They can be observed on entering the solar system. They're in the solar system the entire time. What is the point on the celestial sphere representing the extension of the axis of Earth's North Pole? That is the North Celestial Pole, which currently points near the star Polaris. What is the name of the path in the sky the sun appears to follow as it moves among the stars? That is the ecliptic. Which of the following is part of the interior of the sun? That is the radiation zone, which is the layer above the core, which generates energy. And above that, there is the convection zone. The photosphere is the visible surface. Sunspots are on the photosphere, and the corona is part of the outermost layer of the atmosphere. The part of the sun structure we see in visible light is the photosphere. That's the visible surface. The chromosphere is above it. The core is in the center, and the corona is above that. Which property classifies the star based on its temperature? That is its spectral type. That's one of the ways we can measure temperature. A relatively cool star is red, while of these, a blue star would be the hottest. Red is cool, blue is hot. And because of the nature of the way that thermal radiation works, it turns out there is a color for infinite temperature. It's sort of a nice light sky blue. The fundamental quantity of a star that indicates its ultimate fate is its mass. Mass is the primary determining factor for stars. The Milky Way is classified as a spiral galaxy, specifically a barred spiral galaxy. The key observation that led Hubble to conclude the universe is expanding is the redshift of light from distant galaxies. He observed that they were all moving away. And that is all of that. You can look those up on your own time. So we are going to have the quiz. I am going to stop sharing and end the meeting.